Hello everyone, welcome to this final project demonstration. This is the final project for embedded hardware interfacing at UCSD Extension as part of the embedded software certificate. And this final project will serve as a basis for me to prototype a hardware monitoring as well as step counting wearable. So that would be the goal of this. This is the first iteration of it, which I am also using as a final project for the course. And it has various components. So the goal was to interface various components into a cohesive project. So I went ahead and did that. And first we have here an I2C driven LCD screen. And as you can see here, we have heart rate, steps, and distance. Distance was just another way to squeeze in an extra input, even though in this application case of having a wearable, distance isn't really quite necessary. It was nonetheless cool to envelop everything together. And also, I want to say that this was accomplished using RTOS, FreeRTOS. Actually, I did take a course with the same instructor with regards to FreeRTOS, and I thought it was a great way to combine the two courses together into one final project. So also on the board, we have an onboard accelerometer, which communicates to the board via SPI. So I use that. And then we also have external interrupts. So if I press this button, we get a state change. And this shows us the raw acceleration values of the gyroscope. So these raw acceleration values are then processed. And then I use a pretty crude but still somewhat accurate algorithm to determine the step count currently. And in addition to that, many times in an embedded system, you want to be able to debug and see in real time what the logs are looking like. So I added UART printing, which was extremely helpful when I debugged this, because it definitely wasn't easy. There was a lot of bugs, especially once you have an RTOS involved and you have shared resources. I will definitely post the code on GitHub if it's of interest to anyone. So let's go ahead and look at the demo a bit. Let me go ahead and reset it. So currently, I want it to be known that I don't have a heart rate monitor just yet, but I am working on getting one, and that will be for outside of this class. That is just for further, I guess, for me to have a project to work on for fun. And if you jostle this around, right now I put the sensitivity low on purpose because I don't want to be moving around the cables. But if the acceleration reaches a certain point, a certain threshold value compared to the average, then it will count it as a step. So the heart rate is right now being simulated by a thread that just generates a random value between 55 to 65. But the cool thing here is that we can have multiple threads working cohesively and all using certain synchronization tools such as mutexes and semaphores. Here we have the raw acceleration value. And what's interesting here is that the background never stops computing. So even though you're not seeing an update here of the step count, it really is being updated here. And again, these are the logs. So for future enhancements, I want to get an actual heart rate monitor. There's two types. There's one that you interface via I2C, the other one that you take in the raw data via ADC and do your own calculations that way. I'll explore different options and see what works best. The next step, I definitely do want to add Bluetooth. We did learn Bluetooth in this course. However, due to time constraints and only having less than a week for me to get this together, I did not have an opportunity to do so, but I would love to do that in the future. And then eventually, long term, I would like to actually 3D print a case for this and see if I could figure out to actually make this a wearable watch. And then lastly, I would like to add RTC functionality. I was very tempted to add that now, but I did not want to risk due to time constraints, just because that will take an extra days to perfect it and get it without any critical bugs. So I hope you guys enjoyed this demonstration. So as you can see, step count updates as you rattle this. And yeah, thanks to the instructor as well for teaching us, and hope you guys enjoyed it.